Alright, boys and girls, today's lesson is lesson 6-4, and it is understanding mixed numbers and fractions greater than 1. Alright, so all these easy fractions we've been working on are getting a little bit harder today. We're going to start working with mixed numbers, numbers where you might see something that says 1 and 3/4, okay, or 2 and 5/6. Okay, we're going to figure out what that means. And we're gonna figure out how to add and subtract them and just understand them as the unit goes on. So I want to get started. I want to kind of quickly fly through the first page because I think the first page is kind of easy, but it gets you started on the mixed numbers. So it says a mixed number is a number that consists of a whole number and a fraction. That's a mixed number. Okay, there's a whole number and there's a fraction. Okay. A fraction greater than 1 has a numerator that is greater than its denominator. These two numerators are greater than the denominator, so it is telling you that the answer, your number you're looking for, is more than a whole. It's more than 1. Anytime the number is greater, anytime the numerator is greater than the denominator, the picture that you're looking at is more than the whole. Okay? So let's go through Melly's Deli here. So Melly's Deli makes sandwiches. This is a price list right here. A regular sandwich serves 2, a friendship serves 4, a super serves 10, a magna serves 18. Okay, remember, these are if they made a sub. Serves 2 mean it would be cut in 2 pieces. A friendship pizza serves 4 would be cut in 4. Super would be cut in 10. Magna into 18. It says 19 friends. Okay, that's the main number. 19 friends decide to camp in the park. They order 2 supers. Okay, so they order 2 super sandwiches. Each camper has 1 serving. So, how many campers does 1 super sandwich serve? Well, if you look, it tells you right here, 10 campers. Okay, so what fraction of the second sandwich is needed to serve the rest? Okay, well, you know there are 19 campers. And you know that 10 of them were taken care of on the first one, so that equals 9 people are left over. So the sandwich serves 10 people, and you need 9 of them, so 9/10 of the second pizza, or second sandwich, will serve the rest of the people. Knowing that, what fraction of the second sandwich is left over? Well, you know it started with 10/10, or your whole, and you subtracted 9/10 of it for everybody, and that gives you 1/10 left over. So, what number tells how many super sandwiches the campers ate in all? So, all 19 of the campers, they had one whole sandwich, and then 9/10 of another one. Okay? So, or you could say, had 19/10. Okay, that's where there's 2 ways to write this. You can write it as a mixed number, or you can write it as a normal fraction, where the numerator is bigger than the denominator. 1 and 9/10 or 19/10 is the same thing, because 19/10 is telling you that there are 9 more than a whole. Here, we're telling you 1 and 9/10, we're telling you there's 9 more than a whole. So, let's go to the next page. This is where it is going to get interesting. Okay, we're going to start talking about, well, actually, hold up on the next page just yet. I want to start going over a few things for mixed numbers. Okay, I want to start talking about what you should see, how you should understand a mixed number. So if I have a fraction strip, if they're this long, okay, and obviously my drawing's not the greatest, but imagine these being exactly the same. And this is my whole. Okay, and then let's see. I'm going to cut all these in fifths. Okay. So they're all the same. The whole on top is the same length as all the ones that have the fifths. So, you know, all these are basically, these are 4 wholes. If I look at this right here, my number is 4. Okay? If I were to say what would let's see, 5/5 look like? Okay, hopefully you know it would look just like the whole, because that's the whole. If I say what would 10/5 look like? You would say, oh, easy, it would be 2 wholes, right? Because you would have 1, 2, 3, 4, 5 in one of these, 6, 7, 8, 9, 10. So 2 wholes would equal 10/5. If I said, what would 17/5 look like? You would say, oh, easy. I would take 15. I'll go here and go. I would go 11, 12, 13, 14, 15, 16, 17. Okay, I know I kind of went back at the top. But then you would say, okay, what would the mixed number be for 17/5? Well, look at it. You have 1 hole, 2 hole, 3 holes, and then you have 1, 2 left over of a 5th. Okay? There's ways to understand this. If you have a bigger number on top, like say you have 11/5, okay, those of you looking at this should say, all right, 11/5 is 1 hole, 2 holes, and 1 more 5th, equals 2 holes and 1/5. There's ways to look at it. You could look at your denominator and say, how many times can my denominator go in the numerator? Well, the denominator can go in 2 times with 1 left over. Put that 1 over top of the 5th. Okay, because that's telling you there are 2 holes and then 1/5 left over, 1 piece left over, or 1 unit fraction left over. So 2 and 1/5. Okay, we're going to continue with this. I don't expect you to know it all right now. I'm going to push these right out of the way, and I'm going to make some more fraction strips. Okay, these are all holes. Okay, I'm going to cut them into thirds. 1, 2, 3. 1, 2, 3. 1, 2, 3. And obviously they're not perfect. Okay, 3 holes. What would 3 holes be? Well, let's see. 1, 2, 3 holes would be 9 thirds, right? Because we have them in thirds. It wouldn't be 9/9 because that would equal 1. You would have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 thirds. Okay, because we're counting them in thirds. Okay, so if you want to do the division part, how many times can 3 go into 9? It can go 3 times, equally, no left over, so your answer is 3 holes. Okay, another thing I could do is I could say, well, first I'm going to number all these, 10, 11, 12. I want you to be able to, whoa. If I told you what would 5 thirds look like? 5 thirds. You would say, oh, that's easy because the whole is 3. So here's a whole, that's 1. And then I have 2 left over to get to another whole. So my mixed fraction would be 2 and 2/3. If I want to go back and say how many times can, oh, I'm sorry, that is not 2 and 2/3. That should be 1 and 2/3. All of you hopefully were correcting me. But there's 1 whole and 2/3. If I want to go back and double check, I can say 3 can go into 5 one time with 2 left over. Those 2 leftovers are part of a whole that would be 3. Okay, the whole is 3, so 1 and 2/3. There's a way to go about it the other way. If you didn't have this fraction thing in front of you, the fraction bars in front of you, and I said, okay, if I had a number 3 and 2/3, what is the unit fraction for that? Okay, if I had 3 and 2/3, what would that be as a unit fraction? Okay, take a guess or write down the answer you think, and I'm gonna give you an idea here. Okay. All right. So hopefully you looked at it something like this. 3 and 2/3 would be equal to 1 plus 1 plus 1, right? Because we have 3 holes, it tells me, and 2/3. Okay, so if I were to add it further, I would have 3/3 plus 3/3 plus 3/3 plus 2/3. Correct? Do you see this? Because each of these are 3/3, because that's the whole. Because that's what we're talking about. Their denominator is 3, so our whole is broken into 3. So we have 3/3 plus 3/3 plus 3/3 plus 2/3. So we have 3, 6, 9 thirds plus 2 more, 11 thirds. Okay, that's our mixed fraction. I mean, that's our unit fraction here. That's our fraction. That's our mixed number turning into a fraction. So if you want to double check it, how many times can 3 go into 11? Well, it can go in 3 times. That'll give me 9. I have 2 left over to get to 11, and the denominator stays the same of 3. So 3 2/3. That's one way you can do it if you write them out. There's another way you can do it. You can do 3 2/3 and just use your multiplication. Take 3 times the denominator of 3 plus the numerator, so 3 times the d plus the n. We'll do that first, obviously. And then it equals a number that you'll put over top of the denominator again. Remember, the denominator's not changing here. So 3 times 3 is 9. 3 times 3 equals 9, plus 2 would equal 11 over top of the denominator, which we know is 3, so 11/3. Okay, let me do another one of those for you, because I think I went through that a little quickly. If I have 5 6/7, it would equal 5 times 7, 35, plus 6 equals 41, and then you take that 41 and put it over top of the original denominator, and it's 41/7. Okay, if you want to see if that works all right, 7 can go into 41 5 times to get me 35, 6 left over the denominator of 7. So 5 6/7. So that's how we're taking mixed numbers and we're turning them into fractions. So this will be your work today. We're going to work on this page. You're going to change each mixed number to a fraction and each fraction to a mixed number. I'm going to do a couple with you. I'm going to do a one of each with you, and hopefully you'll understand from there. Number 5, you could take 5 times 3 is 15, plus 2 more is 17, and put it over top of 3, 17/3. Okay, next one, 3 times 7 is 21, plus 3 more is 24, over top of 7. Okay, 24/7. So I'm going to scroll down to a couple of these now. 46. Okay, you can either find all the holes that it's in, or you can say, okay, 6 can go into 40, let's say 7 times. Nope, 42. 6 times is 36, so 6 holes. That gives me 36. I have 4 left over, 6 and 4, 6. Okay, 11 halves. You would say 2 can go into 11 5 times, 5 holes. And there's 1 left over, 5 and 1/2. Okay, so I want you to work on these in Independent Station today, and we'll work on it in small group.